Subtopic seed point to remainder theorem, factor theorem, and zeros of polynomial. What is remainder theorem? If a polynomial Px is divided by linear factor x minus a, then the remainder Pa is a constant. So Px is equals to Qx dx plus R. Qs is quotient, d is divisor, and R is remainder. The remainder theorem applies only if the divisor is of the form x minus a. If Px divided by x plus a, then R equals to P negative a. Means x plus a is equals to 0. So x is equals to negative a. If Px divided by 8x minus p, then R equals to P in bracket b over a. So from ax minus b, so ax equals to b, and x is equals to b over a. Now we go to example 1. Find the remainder when x power 3 plus 3x power 2 plus 5x plus 1 is divided by x minus 3. So from this, x minus 3 is equals to 0. So x is equals to 3. So by using remainder theorem, P3 is equals to, so we substitute 3 into variable x. So become 3 power 3 plus 3, s is 3 power 2, plus 5s is 3, plus 1. Simplify this, so the answer is 70. So the remainder when Px is divided is x minus 3, the answer is 70. Example 2. When Px is x to the power of 3 plus Px power 2 plus Qx minus 9 is divided by x plus 1, the remainder is 3. When Px is divided by x minus 2, the remainder is 9. Find P and Q. So by using remainder theorem, x plus 1 is equals to 0. So s is equals to negative 1. So by using remainder theorem, P negative 1 is equals to 3. So now substitute negative 1 into variable x. Simplify so you can get first equation. From the question, when Px is divided by x minus 2, the remainder is equals to 9. So by using remainder theorem, x minus 2 is equals to 0, so s is equals to 2. Okay, by using remainder theorem, P2 is equals to 9. Okay, now substitute 2 into variable x, so you can get this. Simplify so you can get second equation. Solve the simultaneous equation so you can get P is equals to 6 and Q is equals to negative 7. Example 3. If the expression x to the power of 5 minus Px to the power of 3 minus Qx to the power of 2 is divided by x power 2 minus x minus 2, the remainder is x plus 2. The question is find the P and Q. Okay, now the divisor is x power 2 minus x minus 2. So this is quadratic. So you can factorize. So you can get x plus 1, x minus 2. So to get remainder, when x plus 1 is equals to 0. So s is equals to negative 1. So substitute into a remainder. Rx is equals to, remainder is equals to x plus 2. So when x is negative 1, so substitute negative 1 into x. So become negative 1 plus 2 and the remainder is equals to 1. For x minus 2 is equals to 0, so s is equals to 2. Okay, substitute 2 into x, so you can get remainder is equals to 4. Okay, now when divisor is x plus 1 equals to 0, x is equals to negative 1, the remainder is equals to 1. So by using remainder theorem, p negative 1 is equals to 1. Okay, now substitute negative 1 into variable x. Simplify, so you can get p minus q equals to 2. So this is first equation. For second equation, from divisor x minus 2 equals to 0, so s is equals to 2. From remainder theorem, p2 is equals to 4. 4 is the remainder when divisor is s minus 2. Okay, now substitute 2 into variable x. Simplify, so you can get second equation, 2p plus q equals to 7. So this is second equation. Now you have two equations. P minus q equals to 2, first equation. Second equation is 2p plus q equals to 7. So this is simultaneous equation. By using substitution or elimination technique, so you can get p is equals to 3 and q is equals to 1. Factor theorem. When PA is equals to 0, then x minus a is a factor of px, means the remainder is equals to 0. Example 1. Show x plus 2, one of the factor 2x to the power of 3 minus 3x to the power of 2 minus 11x plus 6. Then find the other factors. To show that x plus 2 is one of the factor, so we can use factor theorem. Means when the remainder is 0, x plus 2 is one of the factor. Okay, so now x plus 2 is equals to 0, so s is equals to negative 2. So now substitute negative 2 into variable x. Simplify and the answer is 0. So from this, when remainder is equals to 0, so s plus 2 is one of the factor of px. To find the other factors, we have to use long division. By using long division, divisor is x plus 2. So this is px. So x multiplied with what is equals to x to the power 2x to the power of 3. So you have to multiply with 2x to the power of 2. 2x to the power of 2 times x. So the answer is 2x to the power of 3. 2x power 2 times 2, the answer is plus 4x to the power of 2. So you have to minus. 2x power 3 minus 2x power 3, the answer is 0. Minus 3x power 2, minus plus, the answer is minus 4x power 2. Simplify, so negative x to the power of 2. Negative 7x to the power of 2. So negative 11x. So next, x multiplied with what is equals to negative 7x to the power of 2. So you have to multiply with negative 7x. Negative 7x times x, the answer is negative 7x power 2. Negative 7x times 2, the answer is minus 14x. So you have to minus. Negative 7, negative, negative become plus, so the answer is 0. Negative 11 minus minus is plus. So simplify, so you can get 3x and plus 6. So next, x multiplied with what is equals to 3x. So you have to multiply with 3. So 3 times x, the answer is 3x plus 3 times 2, the answer is 6. So this is minus 3x minus 3x, the answer is 0. 6 minus 6, the answer is 0. Now, from standard form, Px equals to dx qx plus Rx. Rx is remainder. Now remainder is equals to 0. Dx is x plus 2. Qs is 2x power 2 minus 7x plus 3. And Rx now is equals to 0. So this is quadratic, so you can factorize by using your calculator. So you can get x plus 2, 2x minus 1, x minus 3. Now you already factorized completely for Px. Example 2. Find the value of P if x minus 2 is a factor of x to the power of 3 plus Px power 2 minus 3x plus 6. Divisor is dx equals to x minus 2. So x minus 2 equals to 0, so x is equals to 2. So by using factor theorem, P2 is equals to 0. So substitute 2 into variable x, simplify so you can get P is equals to negative 2. Zeros of polynomial. A is called the zeros of Px if Pa is equal to 0. A is called the root of Px equals to 0 if Pa is equals to 0. Example 1. Factorize Px equals to x power 3 minus 2x power 2 minus 5x plus 6 and write its zeros. Okay, first you have to find one of the factor of this polynomial. Okay, so you have to try and error, means you try to substitute any value of x. So when the answer is 0, so that value is one of the factor of this polynomial. For example, when you substitute x equals to 1 into this polynomial and the answer is equals to 0, that means x equals to 1 is the zeros of Px. To get another two factor, you have to do long division. From long division, you can get another two factor. Now, Ps is equals to, divisor is x minus 1, quotient is x power 2 minus x minus 6. So this is quadratic. So you can factorize by using your calculator. So you can get x plus 2, x minus 3. So Px, when you factorize completely, the answer is x minus 1, x plus 2, x minus 3. So the zeros are x minus 1 equals to 0. So x is equals to 1. X plus 2 equals to 0. So x is equals to negative 2. X minus 3 equals to 0. So x is equals to 3. So the zeros of these polynomials are 1, negative 2, and 3.